So we'll move away from factoring for a bit and go into solving equations. So today it's solving equations and literal equations. Let's look at using algebra to solve equations. So why? The point of solving an equation is to find out what the letter is equal to. So you start with a messy equation here. Oops. Let's change that to the right tool. Start with the messy equation right here. And ultimately, you're going to do some algebra operations, and then you're going to end up here. So in order for this equation to be true, x had to be -2, and there's only one value in this type of equation that will work. So what does that mean? If I went back and I changed all the x's in the original equations to the value -2, I would create a situation where the left side was equal to the right side, and -2 is the only number that will make that happen. So some background for algebra. You know your order of operations. We go from brackets through exponents, then division and multiplication, addition and subtraction, and that's how we do it when we're doing math. Well, algebra is the opposite way. You kind of deal with addition, subtraction first, then division, multiplication, and then finally exponents and or brackets. And I'm about to tell you something that's exactly opposite, but if you were kind of had no other situation, that's what you would do. We'll see in a sec. You can undo any operation with its opposite action. So if I have addition, I can undo that addition with subtraction, and vice versa. And likewise, if I have multiplication, I can undo multiplication with division, and vice versa. And it goes all the way up to if I have a power of 2, I can undo that with a square root, so on and so forth. And I'm allowed to do anything I want in algebra. You could multiply by a pineapple, but you must do left side multiplied by, I don't even know if I can draw a pineapple there. And the minute you multiply the left side by your pineapple, you're going to multiply your right side by a pineapple as well. So generally, we look for operations that are going to help us simplify the equation and get us closer to that point where we say x equals a number. Okay. So there are steps that you take. Usually you get rid of fractions first. So if you had an algebraic fraction or even a numeric fraction, you would deal with that first. It makes your life easier. We'll look at that in another slide set. So we're going to skip right to number 2. Get rid of brackets and simplify on either side. So you're going to use your distribution that you learned to undo your brackets, and then you can start to move things around. So you're going to gather your numbers on one side, and you're going to gather your x's on the other side, and it can be either way around. So numbers on one side, variables on the other. And then you're going to get rid of anything that's in front of your variable to create an x equals blank statement. And then you go back and check your work. So how does it look? So our example question we had right here. So the first step was to distribute. So we distributed the 2 on the left side, and we made 6x plus 16. And on the right side, that negative had to be distributed as well, and we made -x minus 6. At this point, I look at either side, and I see that on my right side I have an 8 and a -6, so I can combine those into 2. All right. Okay, and now here's the part that I want to kind of get into a little more detail on the side. Move terms across the equal sign, changing their sign as you do. So you'll notice that the x is now, it was on the right side, it's now on the left side, and it's positive. So the idea behind that goes back to that I can do anything I want as long as I do it to both sides of the equation. So I want the x to go over to the left side. It's a negative, so I undo that minus x by adding x, and I must do it to both sides of the equation. And the action that happens there, -x plus x, that's 0, right? So what's left behind when you rewrite the equation is just a 2. And on this side, you get 7x plus 16. And likewise, I wanted to move the 16 over to the right side. And I notice when I do it here quickly, if it's plus on the left side, it's minus on the right side. So what did I do? Well, I kind of disappeared it from the left side by doing the opposite to what I saw. I saw plus 16, so I did subtract 16. And then I did my math. And that's how I got to that point. So this is a long way of doing it, but the shortcut is to be like, you can move your numbers and your letters around, just change their sign as soon as you cross that equal sign. If you don't move it, don't change their sign. Okay, so we're at this point where we have almost finished it, and you can probably just guess what it's going to be, but usually do math. So if I have 7x equals negative 14, I want the x to be by itself. I divide both sides of the equation by whatever is in front of the x. So here it's 7, so I divide by 7. And if you notice 7 over 7, it kind of cancels, right? It just makes 1. So this statement is like 1x equals negative 2, which is x equals negative 2. So, and even if you've got a string of strange stuff, you can isolate that x by dividing by everything in front. So I can just divide by 2 pi. I do it to the left side, I must do it to the right side. And I have x equals 17 over 2 pi. So be it. Likewise, if it had been negative 5x equals 13, when you divide, make sure you divide by everything in front. So not just dividing by 5, dividing by negative 5. Because otherwise you're going to tell me negative x equals something. And I'm not interested in what negative x equals. I'm interested in what x equals. And if it had been division instead, that the x was trapped by division, I would use multiplication to undo that. I would do it to the left side, which would cancel the 2's, and I must do it to the right side. So x would be equal to 24. Okay, we're going to take a look at a couple of examples. So no fractions in number 1. I'm going to distribute negative 6 into the brackets here. So I have 3 minus 12, and I'm going to have plus 18x equals x minus 5. I see on this side I can gather those. I mean, you can move stuff separately, but it's faster to gather, less mistakes happen if you do that right away. 3 minus 12 is minus 9. I'm going to bring the x to the left side and the negative 9 to the right side. And it doesn't matter if your x's end up on left or right. I tend to try and get rid of negatives, but you know, I'm not picky. So when I do that, I'm going to have 18x that was already on the left side, and now I'm going to have minus x because it crossed the equal sign, so its sign changed. And on the other side, I had the negative 5 stays, and then the 9 has crossed the equal sign, so I'm going to add it. Okay. Do the math, collect like terms. 17x is equal to 4. And then divide both sides by 17 to isolate the x, and you're going to get x equals 4 over 17. Looking at the second question, we've got a lot going on, but I'm going to deal, because it's like there's invisible brackets all the way around this, so I'm going to deal with the 3 first. And in order to deal with the 3, I'm just going to write it here, I multiply both sides by 3. That leaves just a numerator. And on the right side, I have 24. Okay, we're going to distribute our negative 2 to get rid of the brackets. 4x, and that becomes minus 2x plus 8 equals 24. I can gather a bit on this side. 4x, and I have 2x plus 8 equals 24. And my second last step is I'm going to move that 8 over to the right side by subtracting it from both sides or just recognizing that I moved it. So I'm going to flip it when it hits to the right side and be minus 8. 2x equals 16. Last step, divide both sides by 2, and I get x equals 8. Okay, I told you that we aren't going to deal with fractions, so I want to just kind of let you know what's going on here. So if you have a situation where it's fraction equals a fraction, and not fraction equals fraction plus whole number, fraction equals fraction plus fraction plus fraction. So it has to be 1 equals 1, 1 for 1. You're allowed to do cross multiplying in this situation. You don't have to use the lowest common denominator or do all the other stuff that we're going to figure out. So cross multiplication, you need to have an equal sign in between two fractions, and you basically take, in the pink, you're going to do 3 times x plus 7. Use the brackets because these are essentially bracketed. Equals 4 times x minus 2. And once you get rid of those fractions, everything becomes a lot better. So we're going to distribute on the left and right side. 3x plus 21 equals 4x minus 8. This time I'm going to send, and this is my own personal preference, I don't care what you do, I'm sending the x to the right side because it'll make a positive instead of a negative. Okay, so the x is going over to the right side, and on the left side we're going to have the 8 come over and be positive, and on the right side we're going to have the 3x go over and be negative. So I'm going to end up with 29 equals x, and I'm done right away. On my last slide thing, so noticing a different type of situation. This is a quadratic. It's going to make a trinomial. So when you do these, you don't put x's on one side and numbers on the other side. You are going to bring everything over to one side and set the equation equal to 0. That's how you solve these. So I'm going to bring that 2 over and have minus 6. And then I'm going to factor on my left side. So I'm going to use my factoring skills. Talked about it before. And you end up getting into this situation. So in order to make this equation true, I have to have the left side equal 0. So how do you make 0? Multiplying by 0. So I could have a situation where this was equal to 0, and 0 times x minus 2 would equal 0. Or I could have a situation where this binomial is equal to 0, and then 2x plus 3 times 0 would equal 0. So I'm just going to pick values of x that make 0. And of course, this time I'll have 2. So if I had 2x plus 3 equals 0, just use some algebra. Move the 3 over, isolate the x. So x could be negative 3 over 2, and much easier. X could also be 2. So you have two answers for these ones. Either negative 3 over 2 or 2 will make the equation equal to 0, and it will make it true. Let's take our algebra skills and deal with some literal equations. So what does this mean? We're going to rearrange formulas. So we're going to take our algebra and we're going to take a formula that may have looked like something here. Perimeter is equal to 2 times length plus 2 times width, but I want to know what width is equal to. So I'm going to move stuff around and get my formula to be W equals something. So here we go. Okay, so my original formula, I want to solve for little p, but right now it is for big P. So I'm going to write it down again. And we're just peeling the onion here. So the first thing I see is I can get rid of that n, which is stuck on the brackets by multiplication. So I'm going to divide both sides by little n. And I'm at p over n equals little p minus I. I'm going to come up here, and I'm going to send I to the left side, and I'm going to have big P over n plus I equals little p. And there you are, isolated little p. Okay, my second example, I need to get big P out. Okay, so we have an 8, a whole bunch of stuff going on. Remember, that's like there's brackets around it, and I really need to get that 8 out of there. So the first thing I'm going to do is multiply both sides by 8. And that will change it into 8w equals L, crazy bum L, plus 2. Now let's divide out this big L. And there's often more than one way to go around about these. Okay, I'm going to move the first term on the right side over with subtraction. Okay, and then I'm going to move the 2 over. So I'm going to divide both things by 2, and just being careful about how that affects your left side. So if I have 8w over L, I divide it by 2, I can rewrite that as 4w over L, but my second funny w is going to stay as a fraction. All right, we want to get this guy out. Same thing, I'm going to start by taking VO over, and that gets rid of the first set of brackets. Okay, let's get the 1 over to the other side. Okay, let's divide everything by b. So just knowing our fractions, we'll turn that into this kind of thing. And now I've still got t minus to. And my final step to get that t by itself. TO equals T. Now, like I said, there are a lot of different versions of how this could look. So I will make sure, as long as it's equivalent, I'm happy. And our Fahrenheit conversion formula. All right, so we want to get the Celsius out of there. So we start by moving the 32 over. Remember, working opposite your order of operations. Fahrenheit minus 32 equals 9 over 5. Celsius, you can do this in steps. You can divide by 5, or sorry, multiply by 5, then divide by 9. But just also knowing that if you want to get rid of a fraction, you can always multiply by its reciprocal. And that will get rid of the fraction, and you end up with C equals 5 over 9 F minus 32. And you don't need to incorporate that, that is fine. Okay, I see D is here, it's also squared, that's fine. Do everything at once. I don't want the S and the L on there, so I'm going to divide the whole thing out. So I have Q over SL equals D squared. The opposite action of an exponent is a root to the same power, so I'm going to take a square root of both sides to isolate D, and I end up with plain old D equals the root of all of this. A similar one here, r is squared. Okay, I'm going to deal with the 1/3 and then deal with the rest of it. So if I want to get rid of this, or another way to think about it is this formula is the same as this, right? So I'm going to multiply both sides by 3. So I get 3v equals pi r squared h. I want to isolate r, so I'm going to start by dividing, undo the multiplication before you undo any squares. And then I'm going to proceed to, because I'm at this point, and notice I'm flipping back and forth, left and right, that's fine. As long as I don't change the values. Take that last step, get the root, and then you have your final rearranged formula.